In this video, we will learn the vascular lesions of medulla oblongata. To understand the vascular lesions of medulla oblongata, we need to understand the blood supply of medulla oblongata. So, in this diagram, these are cerebral hemispheres. This portion is brainstem, which includes midbrain, pons, and medulla oblongata, and this is cerebellum. So, medulla oblongata in paramedian region is supplied by two vertebral arteries. The dorsolateral part of medulla oblongata is supplied by posterior inferior cerebellar artery, which also supplies posterior part of inferior surface of cerebellum. The median portion of medulla is supplied by anterior spinal artery in front and posterior spinal artery behind. Apart from this, the ventrolateral aspect of medulla oblongata is supplied by anterior inferior cerebellar artery, which also supplies anterior aspect of inferior surface of cerebellum. Both the vertebral artery unite and form the basilar artery, which also supplies some part of medulla oblongata. So by and large, medulla oblongata is supplied by following arteries: a pair of vertebral arteries, a pair of posterior inferior cerebellar arteries, a pair of anterior inferior cerebellar arteries, anterior spinal arteries as well as posterior spinal artery, and basilar artery. The common vascular lesions involving medulla oblongata includes: first one is the thrombosis of this posterior inferior cerebellar artery, and the second one is thrombosis of vertebral artery. The thrombosis of posterior inferior cerebellar artery leads to lateral medullary syndrome, and thrombosis of vertebral artery leads to medial medullary syndrome. We will see effects of both these syndrome one by one. In lateral medullary syndrome, there is thrombosis of posterior inferior cerebellar artery, which supplies dorsolateral aspect of medulla oblongata as well as posterior part of inferior surface of cerebellum, which we learned during the blood supply. So, the effects of lateral medullary syndrome will be due to the damage of those nuclei and tracts which lie in dorsolateral aspect of medulla oblongata. So let us see what are those nuclei and tracts that are affected or damaged due to thrombosis of posterior inferior cerebellar artery. One of those structures is lateral spinothalamic tract. The second one is spinal nucleus and tract of trigeminal nerve. The third one is this nucleus ambiguous. The fourth one is this reticular formation, and the fifth one is this vestibular nuclei. So effects of lateral medullary syndrome will be due to the damage of these structures. So we will see those effects one by one. Damage to lateral spinothalamic tract leads to contralateral loss of pain and temperature sensation from the trunk and limbs. Damage to spinal tract and nucleus of trigeminal nerve leads to ipsilateral loss of pain and temperature from the face region. Damage to nucleus ambiguous leads to paralysis of the muscles of palate, pharynx and larynx, which may lead to dysphagia and dysarthria. Damage to reticular formation lead to the damage to descending pathways which traverse through the reticular formation, and that damage to the descending pathway leads to Horner's syndrome. These Horner syndromes you already learned during the injuries of brachial plexus, which is having 5 components: ptosis, meiosis, anhidrosis, anophthalmos, and loss of ciliospinal reflex. Damage to vestibular nuclei leads to giddiness, and as this posterior inferior cerebellar artery also supplies posterior part of inferior surface of cerebellum, thrombosis of this artery leads to cerebellar symptom which is known as ipsilateral cerebellar ataxia. In this ipsilateral cerebellar ataxia, there is loss of coordination of balance, gait, extremity, and eye movements. In medial medullary syndrome, there is thrombosis of vertebral artery. And as you already know, vertebral artery supplies the paramedian region of medulla oblongata. So, the thrombosis of vertebral artery will lead to damage to pyramids, medial lemniscus, as well as hypoglossal nerve. Damage to pyramid will lead to contralateral hemiplegia or paralysis of arm and legs. Damage to hypoglossal nerve leads to ipsilateral paralysis and atrophy of half of the tongue. And damage to this medial lemniscus will lead to contralateral loss of the sensation of position, vibration, and tactile discrimination. Lateral medullary syndrome is also known as Wallenberg syndrome, and medial medullary syndrome is also known as Dejerines anterior bulbar syndrome.